Hello, you're welcome back. And yeah, this is Quiver Analytics, and we resume our class on Python for data science. All right, so I'm starting my Jupyter. Again, I'm starting from starting up the Jupyter interface, the Jupyter notebook. All right, so like I would always say, when you click the Jupyter notebook, the icon, anywhere you have it will bring out these codes, and then you would see to instruct you to copy something. Mine would start immediately, like that's how it ought to be. You can see it starting up here. Well, because I said that this edge is a little bit slow, so I'm going to copy this address and paste it on my Chrome. Okay, all right. So it's to take a few seconds, and that's it. So now I'm going to navigate to my to where the folders, I mean my scripts are. So for this class, I have it here, and then Python for data science for data visualization, right? Well, a little bit, I mean, this is a little bit slow today. Normally it should be faster. Now the objectives are enhance, I mean, to by the end of this lesson, learners will be able to one, use Matplotlib, use Seaborn, customize plots, visualize real data sets. All right. So now, if, in case you are using an interface that does not have Matplotlib and Seaborn and pandas pre-installed, you can run this code pip install matplotlib seaborn pandas, then it installs it. But if you are using Chrome or Edge, you might not need to run this. Of course, if you run it, it will work, but you don't have to. All right, so using Matplotlib to look at some basic plots. All right, so I'm going to clear clear um output for all cells. All right, so I'm going to import the library for Matplotlib here as PLT. All right, so now, because of course there's no prints, there's no outputs, then now the first plot we'll be considering is the line plots. A line plot displays data points connected by lines, ideal for showing trends over time or continuous data progression. So we can see this is X indicating for X axis, and this is Y indicating for Y axis. All right, can be anything. What matters is where we put it here. If you put the X first, it puts X in the X axis, and if you put it last, it puts it in the Y axis. All right, so in essence, your x-axis should come first, followed by your y-axis. All right, so we have x 1 2 3 4 5. I can add another one, 6. If you've been following, you would know that this is a list, and this is a list. Okay, so y13, I mean list x and list y. So now the prompt for the charts is plt.plot. Remember, we have brought in matplotlib as plt, so we are saying plots xy. That means that the plot is for line charts, and then the title is simple line plots, and I mean sample line plots. Then x-axis, y-axis, grid line equals true. So let me leave this, and you see what it does. So this is the grid line. This is the lines that was drawn. You can see here 6 for 13. This is 12. 13 should be around here. All right. So if I remove the grid lines, you would see that there will be no grid lines. All right. So it's used lines to connect. So when x was 1, y was 2. Let's see. When x was 1, y was 2. When x was 2, y was 4. When x was 2, y was 4, so and so on. So that's how this line was produced. bar plots, all right, so we are all familiar with bar plots, is used for to represent categorical data. All right, so let's see. Our groups now, we have A, B, C, D, and score we have 10, 15, blah blah. Then we have groups, like I said, whatever should be in your x-axis should come first, while y-axis should come later. All right, so the same editing, no grid lines here, and we have the bar charts. For scatter plots, so scatter plots shows relationship between two numeric variables using dots. It's like your line plots, but we use only dots. I mean, without putting the line. Then it's what it tries to check. What it tries to check is if there is linearity within the two data sets. All right. So, like I said in the class, when we get to um, correlation analysis, you know more about this. So for Seaborn for statistical visualization, we have now that's all for Matplotlib, but the Matplotlib can do like it can create more charts than this. But for demonstration in this class, we'll just limit it here. Then for Seaborn, we are importing Seaborn and then pandas. That's because we'll be using pandas, I mean data sets from a pandas data set. All right, so we are bringing the Titanic data sets. If you are familiar with the movie Titanic, so we have survived, those who survived, those who did not survive, the class of the passengers and all of that. So continuing from with our charts, we have histogram charts. The histogram um, group continuous data. It groups continuous data into bins and display the frequency of values, blah blah. So it tries to group continuous data into bins. These are bins. You can see here we said bins equals 20. Then this KDE here does not have to be there. KDE is for the line chart that was imposed upon, to depict the figure that was presented by the histogram. The histogram is the bar chart that is joined together. All right, so you can see the title too. It has to be in quotes, age distribution of passengers. Now for box plots, it's used to show the distribution, that's median and variability of a data set. It also shows outliers. So for box plots, we'll be looking at three things. The first one is a general box plot for age, and we've seen the histogram distribution of age. This is what the box plot looks like for the same variable. So here the box plot is showing us outliers here. So then this is the median value. The middle here is the median value. This is the 25 percentile. This is the 50th percentile, which is the median. This is the 75 percentile. All right. So we can split for the box plots. We can split it by um, gender. Yeah. So our x equals sex, then y equals age. Then box plot is the command. All right, so you can see here, from here we can see that all of the outliers belong to male gender. All right, then we can also split by survival. So you just replace your x by survived, and you can see some people who survived. We have the eldest person survived here. All right, so um, then their median age is almost the same. All right. Then for the correlation its map, again, this is something we'll be talking about in depth in the correlation analysis. All right. So the correlation measures degree of relationship and size. The yeah size and direction of relationship. So here you can see some of them are negative, some are this is positive, and none of them, apart from this diagonal, none of them is 1. It simply means that correlation values are between 0 and 1. They can be positive or negative. The stronger correlation tends towards 1, the weaker correlation tends towards 0. So as your correlation tends towards 1, it means strong correlation. As it tends towards 0, weak correlation. And tends towards 0 rather, 0, weak correlation. You can see the color here is strong, the red color here is strong, the blue color here is strong, and as they fade away, as the red also fade away, that means the smaller the correlation, the weaker the correlation. So a correlation of 0.0 is really, I mean, no correlation. Yeah, 0.0 means no correlation. All right, 0.2 means weak positive correlation. Minus 0.2 means weak negative correlation. All right, so to customize plots, okay, so here, what we did here is that we customize the legend. You can see label equals line A. You can see line A here. Then color equals green. That's the color of the line. Then line type, we use dots, I mean dash dash. So that's why we have broken lines. Then the marker 0. So these are things you can use to customize your line charts. All right. So we can also adjust layouts using this. So using the plc.tight layout. All right. So you can see it here, tight layout, fixed overlapping text. All right, so here what we want to do is produce a chart or two charts that are beside each other. All right, so you can see axis 0 bar charts, set type 2, then scatter charts. We want to produce a bar chart and a scatter chart. So you can see the bar charts and the scatter charts. Now we have white lines here, we have lines in between, but if I add the plc.tight layout, if I add it to the code, you can see the white empty space here is limited, and here everything is compact as well. So that function tight.layout makes everything compact. All right, now for group bar charts, side by side bars, you know, when but when we have two or more categories to compare, we use the group bar charts. All right, so you can read this up. Now let's plot the group bar charts. All right, so you can see here we have the passenger and gender. In the the first class passengers, we have more male than female. In the second class passengers, we have, of course, more male than female. And the third class, we have a lot of the proportion at which male and female is higher than female is so much here. And it gets little and little as it gets to first class. All right. Now, the other chart that looks like it is the component bar chart. For the component bar chart, it does not put the bars beside each other like this, like the group bar charts. It puts it on top each other. And what makes that possible is this stacked equals true. Stacked equals true. All right, so that means stack it on top each other. All right, so if we run this, so we have this. It's the same thing, but it's quite more difficult to interpret using this. So I prefer using the group bar charts over the components bar charts. All right, so now, and one thing we did here is to, for the legend again, we gave it title equals legend, and lock is upper left. That means lock it on the upper left. You can change it to upper right. You can change it to upper middle, middle, or upper middle. You know, keep changing it. You can even use axis to change it. All right, so that's in case your legend, if the legend is here, let me change it to upper right. If the legend is in upper right, it will interfere with the bar. It should be, you can see it's over the bar here. So I'm going to change it back, Control Z, and then run it, bring it back to the left. So customizing axes and labels again. So if you have a bar chart A, B, C, D, and then blah blah, simple bar charts. So now looking at this, to customize the label, we can do rotate equals 45. So normally we have by default we have axis like this, that's like 180 degrees, but here if we want to make it 45, we want to make it slanty, we do that when the labels are like long, when they are long, so we just slant it. All right, so let's do that. So looking at the labels now, we have A, B, C, and D slanted. All right, then editing legends, we have okay, so we plot another one, and so here we have data line. We've done this before. We also edit the legend. That's plc.legend, legend title, upper left, then front size small. You can make it big, you can make it mid or medium rather. All right, so now conclusively for the multiple line charts, another type of charts we can do now we often see is a multiple line chart. So it's actually plotting different line charts. Remember, for one line charts, we did plot. So we repeat the same thing and plot. You plot its the number of lines that you want. So here we have three uh, continuous variables as three numeric variable lists 1, 2, 3. That's why we have plotted them on the same charts. All right, on the same graph. So you can see the three of them here. All right, so you can look up the code. You can see PLT grid, tight layouts, everything is there. You can look up the code. Then for the assignments, you have to look at the Titanic data again, and then try to produce all of this. All right. Okay, so thank you, and see you in the next video.